And of course, it's not just that the water is getting warm, it's that the corals are connected with corals in other locations. Their babies come from the British Virgin Islands. Their babies come from Down Island. Their babies go to other islands. It's all connected by this sort of hydrodynamic conveyor belt going back and forth.
Welcome to Diving into the Discourse. My name is Carmen Ramos Chandler, and I'm your host for this episode. And today, we're talking to CSUN marine biologist Pete Edmunds. Pete has spent more than 30 years studying the state of coral reefs, particularly in the U.S. Virgin Islands and in French Polynesia. And his work has laid the foundation for understanding the current state of coral reefs as climate change impacts them. So thank you for joining us, Dr. Edmunds.
Thank you, Carmen. Lovely to be here. It's always a pleasure to talk to you about our marine biology research.
So let's start with a simple question. Why coral reefs, and why did you start it so many years ago?
I grew up in England, and as a child, I watched Jacques Cousteau for many, many years, and I always wanted to be a marine biologist. And my marine biology career took me to Newcastle University in England, and there I stumbled into a lecture hall of a charismatic Professor Barbara Brown, and she turned me on to marine biology and to coral reef biology, and I've been lucky never to look back.
So you're one of the very few researchers that has chronicled nearly every single year the state of a coral reef. Explain why that's important, and what information have you learned over the years?
Our world is changing around us, and the world is changing due to climate change and a wide diversity of other events. And we listen to our favorite news show, and they talk about how the world is changing, and we don't often think where that knowledge is coming from. And where that knowledge is coming from is from people like myself and my graduate students and others who've made a lifelong commitment to return to the same spot in the world, whether it is a coral reef or a mountain or a lake or a fjord, and record it year after year after year, and to do the same thing all the time over that long period in a standardized way. And that's the only way that we know how the world is changing. And now, as we seek to understand what humanity has done to the world and how the coral reefs of the world and natural resources will change in the future, the information that I and my colleagues have collected is the only means to reconstruct the past.
How do you collect this data, and what are you looking for?
Arguably, we're not looking for anything. We are documenting what is there, and we're trying to describe abundances and sizes and diversity over a period of time. And I think some of the things I love about the nature of this work the most is that so much of it relies on natural history and counts in an identical way. And while the work of myself and my colleagues often involves fancy tools and expensive technology and fancy computers, the basic work of monitoring the environment is simply you get in the environment and you count what is there in a fixed area, usually a 1 meter square of PVC or a large number of photographs that originally were on Kodachrome film and then turned into digital images. But you're doing the same thing in a standardized way year after year. And then you add that information together, and that identifies the trends that you're seeing, how the world is changing.
Explain to those people who are naive, what are coral reefs and their importance in the marine ecosystem?
Coral reefs are the most awesome of the marine biology world's assets. Coral reefs are built by animals. They are found in tropical warm seas that are barely lower than maybe 82 degrees Fahrenheit or 27, 28 degrees Celsius. And they fringe tropical islands. They form incredibly diverse ecosystems. They support vast fisheries. They're economic engines of tourism. They are just fantastic resources. Those are places where coral biologists go to be born, where you have these awesome experiences understanding the diverse world around us.
Now, when we think of coral, I think what we think are those spiny trees, but coral come in a variety of shapes. They're not just trees.
Hollywood sells us a false bill of sale, and Hollywood portrays a coral reef as a branching structure of blues and pinks and violet colors. And yes, you can find corals that look like that, but the vast majority of corals are a more mundane, greeny, brown color, and they produce giant hemispheres, and they produce giant boulders, and they produce giant columns, and a few of them produce some very beautiful branch-like, sort of stick-like colonies.
And what kind of marine life depend on the reefs to survive?
Well, I think probably the most charismatic marine life that people tend to think of are the fishes that hang out on coral reefs. The large fish, the sharks, the small fish, the little blennies, and the smaller fish that hang out among the coral colonies. But within that framework is this wonderful diverse array that the reef builds the habitat, and once you've built the habitat, they surely come. And so you have sea urchins and brittle stars and sponges and sea squirts, all kinds of cool little animals hanging out among the safe haven of the corals.
And I would assume, since it's a pretty cool ecosystem to look at, humans depend on those reefs as well, whether it's for tourism or...
The human dependence on coral reefs is phenomenal. The number of humans that live within 50 miles of a coral reef is in the hundreds of millions. The number of people that depend on coral reefs for protein and food resources is vast. But I think perhaps what really hits home is the billions of dollars of revenue that are dependent on tourists going to coral reefs for coral reef-related vacations. You go to the tropics to sit on a beautiful white beach that comes from broken up corals, to swim in crystal clear blue waters. And fortunately, I think a number of tropical islands and tropical communities are now realizing the true value of their coral reef lies in preserving it for posterity, for the economics of tourism, rather than the shorter-term gain of fisheries resources.
Now, you have been visiting St. John's, or the reefs off St. John's, for more than 30 years. First, why St. John? And then, what have you seen over that course of time? I mean, we've had hurricanes, we've had bleaching, we've had rising water temperatures. What are you learning as you compare the data you collected 30 years ago, 31 years ago, to the data you're collecting now? Because you're still doing research.
Well, I'm pleased to say that 2024 is my 38th year of returning to St. John. And strangely, it didn't start from exhaustively surveying the Caribbean, thinking, my goodness, what would be the best possible place to work at if you had all the money and all the opportunities and you picked the best biology. Strangely, I started working in St. John because that was my first job out from my PhD program. And so I had a fresh PhD in my pocket. The ink was barely dry, and I was offered a job in the United States Virgin Islands, and that was where I went in 1987. And I had such a wonderful time there, being inspired. I learned how to teach there, and the teaching I learned there I bring to the halls of CSUN right now, and I learned about coral biology. And so that's what started the project. And once you've committed to a particular location, it's easier to return, it's more effective to return, and that's allowed me to see how those reefs have changed. And you're right. Over 38 years, my goodness, there's been so many disturbances, and it seems like the coral reefs can barely get a break. It's a hurricane, and then it's a coral bleaching, then it's another hurricane, and then another hurricane, and then a disease comes by, and then something else. And so one of the really big questions right now is how are reefs changing as a result of short-term shock disturbances, like a hurricane that could come by and devastate a reef in just 8 or 9 hours, versus chronic disturbances like very gradual increasing seawater temperatures. And what I have seen is that each year it's a death by 1,000 cuts. Each year the coral reef dies back by 0.5% or 1% or 0.25%. And if you just looked at those reefs in 2 years apart, you'd barely notice a difference. But of course, if you then take 38 years of 0.5% or 1% and you add that up, that is a lot of change. And so I think what I have seen is these reefs being beaten back by acute disturbances that catch the attention of the casual observer. But the real story is the chronic loss every single year.
How does it feel to see that loss? Because it's not just, you're not the tourist who's there for maybe 2 weeks out of a lifetime. You're there for weeks at a time for 38 years. You know these reefs intimately.
That's a very interesting question. This summer and spring, I've given a couple of talks to college groups, and perhaps it says more about the state of the young college students' minds than anything else. But a number of folks have asked me, well, how do you remain positive when you see so much loss and death and change in the environment? And it is a really telling question, because I've seen my friends die out on the coral reefs. Coral boulders I have known for 30 years. I've gone out to my study site, and every year it's been get in the water, at the boat, swim out to the headland, kick, turn left at the beautiful pillar coral, and there is your study site. And so now I've started like, oh my goodness, the coral I've known for 35 years is dead. And definitely, that makes you a little sad. But I think, my job is somewhat like yours. I'm a reporter. My job is not to get wrapped up in the sort of emotional side of the story. All I have got to sell is the truth. And so I do my best to report the truth. And it's all interesting. It's all fascinating. And certainly the loss of the stony coral is very saddening, and you think how that will affect the reefs of tomorrow. But the biology is fascinating. Trying to tell the truth is fascinating, and it's a responsibility, and it's a burden. I can't let myself get too wrapped up in the emotional side of it.
When you're watching, and you've watched the stony coral, for example, die off, what do those shifts in the neighborhood on that reef mean? Or what are they telling you what's going on in that neighborhood?
That's a very good analogy. It's kind of like gentrification in a select neighborhood, or a neighborhood deteriorating. And the neighborhood effect is profound. As the stony corals die back, then you have other organisms come in, select fishes become less common, other players become more abundant. So, for example, we've seen this proliferation of algae, and the algae are the prolific plants of the sea, if you like. And, they create a very different habitat. If you love algae, you love algal-dominated coral reefs. But if you love corals, you're not so excited to see the proliferation of algae. So you see very profound neighborhood effects. And we often call it a shifting baseline, that you go there for the very first time. It's like, oh my goodness, it's so awesome. There are all these fishes and there are all these algae. It's lovely. And I'm standing on the sidelines saying, well, oh my goodness, you should have seen this in 1989. That was a community. And so the neighborhood effect is very profound. And I think when I look at the optimistic side of how reefs are changing, it's the fascination of the different neighborhoods and how they're changing, what they bring to the table, and trying not to add a sort of a biased prejudice to what I think about those different neighborhoods.
What has been the impact? Because you and I have been talking about the status of corals, and we're just focusing on St. John at the moment, which is in the U.S. Virgin Islands, or off the island of St. John, the reefs that you study. Because they are ours. The corals you're looking at belong to the United States. They don't belong to somebody else. They're ours. And while they're not as sexy as a Great Barrier Reef, they're still ours. What have you seen is the impact from climate change? Because I often think of the corals kind of like our canaries in the coal mine. They're telling us things are happening. Pay attention. What are you learning as you watch the temperature rise?
Well, the canary in the coal mine is a good analogy. And the Virgin Islands is a wonderful place to study these canaries in a coal mine. And St. John is 75% national park, so a lot of it is pristine, and that's one of the joys of working there. You can stand on a cliff, you can stand on a beach, and oh my goodness, the whole watershed is green. There's no development at all. And so it would be lovely to think, well, these are some of the best protected coral reefs in the world. They're in a United States National Park Service area. They're fully protected. And you might think, well, my goodness, they should do better than other areas that are less well protected. And I think that is perhaps the most sobering outcome of some of my work, that those reefs in the Virgin Islands, with all the protection that the United States and the National Park Service can afford to protect them, it hasn't really mattered that much, because the main drivers of their death and their mortality is not a local golf course, or not an urban area, or not an oil refinery. It's the fact that the water is getting warmer everywhere. And that dubious trend is not owned by anybody. It's part of our world. And so the reefs in the Virgin Islands are affected by water that's getting warmer Caribbean-wide.
Yeah, there isn't a wall around these reefs that keeps the water out and keeps the water separated.
And of course, it's not just that the water is getting warm, it's that the corals are connected with corals in other locations. Their babies come from the British Virgin Islands. Their babies come from Down Island. Their babies go to other islands. It's all connected by this sort of hydrodynamic conveyor belt going back and forth.
As the community of coral shifts, now the coral, when they die, provide, how to put it politely, their bodies, the remnants of their bodies provide the foundation for the building of the reef itself. The corals are actually living entities. They're not these pieces of rock. And when they die off, they provide that foundation for the shelf. But if they're not there, what happens to that shelf?
Well, slowly that shelf will decay and break down. And one of the stories we've been able to tell is how some of the stony corals have been replaced by soft corals. And soft corals are indeed soft. And they're flexible and they wave around in the water column. And if you swim over a soft coral reef, you'll be blown away by how beautiful it is. It's towering, tall colonies. There'll be fishes swimming in between. It's beautiful. But a soft coral colony is soft and it doesn't produce the stony framework. And as the stony corals have died off and they've been replaced by soft corals in the Caribbean, you don't have this wave-resistant platform. And as we start building that wave-resistant platform, then the forces that break it down, whether it is storms or whether it is sea urchins grazing or whether it's bioeroders, progressively they get the upper hand and the whole framework will slowly break down and decay and break up. And that will be a tremendous loss of habitat and it will be a tremendous loss of coastal protection.
Yeah, I was just wondering about, because if those shelves die off, they restructure basically because the stonies are gone and now you've got the light, pretty but delicate soft coral there. We may not be aware that that reef is actually providing us some protection from the ocean. It's kind of providing us a barrier. We humans, we're very arrogant in assuming that the world exists for us and not recognize that this whole community has been protecting us from the impact of rising waters, so to speak, because they hit that first before they hit us. Waves aren't just on the top of the water, they're currents underneath. Can that change our environment on land? At least those along the coastal communities there?
Well, absolutely. Think of Florida and think of the Florida Keys and the flooding and the wave damage we're seeing more recently in the last sort of 5 to 10 years is in part because of the loss of the stony corals offshore. And the corals will dissipate the wave energy, and depending on the type of reef you have there, you can have an offshore reef crest and you have the beautiful foaming white waves breaking on the reef crest, and they're breaking there because there's a barrier. And if that barrier is gone, then those waves, the next stop is the shore, and the next stop is where your coastal property is located. So you get a tremendous amount of coastal erosion and damage if those coral reefs have gone. And where we work in the Caribbean, it's a fascinating place, but it's a small vignette of the global story of coral reefs. And you go particularly to the Pacific and you think about the Great Barrier Reef, and you've got this Great Barrier offshore. And if that barrier is to break down, then the waves just roll straight over the top and hit the land. And again, that will be a tremendous loss. And some countries who are low-lying, like the Cayman Islands, like the Seychelles Islands, like islands throughout the Pacific, if seawater rises by just a few feet and the sea level rises and the corals break down, those islands are in jeopardy. They'll be flooded out and will be gone.
You mentioned coral reefs. I don't think we recognize the global impact and how they actually are kind of connected. But you also do research in Moorea. Tell us about that type of research.
Well, I am incredibly lucky. I have the best job in the world. I get to work in the Caribbean, in the United States Virgin Islands. And then since 2005, I've been lucky to be one of the co-PIs of the National Science Foundation's long-term ecological research site in Moorea, French Polynesia. And that is this gorgeous location in the South Pacific. It's about 7,000 miles from Los Angeles, 7,000 miles from Sydney, 7,000 miles from Tokyo. And it is a teeny weeny little pinprick in the middle of the South Pacific. And you fly out there in the airplane and it's blue and it's blue and it's blue and it's blue. And then there's this pinprick of the island. And we started studying in Moorea, doing much of the same sort of things I've been able to do in the Caribbean. The project is much grander. There's more people. There's more funding. And it's a very different location. Fortunately, for much of the last 20 years, the story has been much rosier there in terms of how the coral has died and how it has regrown and the number of babies arriving. And it's produced a very interesting contrast to the Caribbean. I wish more of the Caribbean was like French Polynesia.
What do you attribute the contrast to? Is it because of the location, the lack of human contact with the island? Well, there are a lot more humans closer to the U.S. Virgin Islands than there are in French Polynesia.
It's hard not to place some blame of the number of people in the Caribbean. And, excuse me, the Caribbean is a much different location to the Pacific. It's largely enclosed by land between South America and North America. The water motion there is very limited. The water depth is relatively shallow. And you go to the tropical South Pacific, and it is just a mind-blowingly different place. Within a mile of shore, you're within thousands and thousands of feet of depth of water. And I love sitting on the flight going out there, and the airline will have their flight magazine, and in the back of the flight magazine, they'll have the route map of the airline. And one of their issues overlaid that flight map on Europe. And I was blown away by realizing French Polynesia extends from Ireland in the west to Israel in the east to Norway in the north and Sicily in the south. And that kind of gives you an idea. Oh my goodness, it is such a vast area of thousands of islands scattered over such a large area. And so you have a lot more populations of corals in a lot more places with a lot clearer water, a lot more rigorous hydrodynamic wave regime. And it's like, well, that's clearly part of the puzzle here, a very big part of the puzzle.
But are those coral also being impacted by the shift in the climate, the warmer?
As I said, I mean, global climate change is a global phenomenon. You can't escape it, unfortunately. And I think French Polynesia has a lot less sort of pre-existing conditions, kind of like in a human sense. And so the high temperatures arise and the corals are doing a little better when the temperature comes, and they too will often die out. But it's much more of a mosaic of reefs. And so you have one reef that is doing poorly, and next door to it will be a reef that's doing well, and on the reef that's doing well, its babies can drift around in the water column and seed the adjacent area. And so they're affected by many of the same things, particularly high seawater temperature leading to coral bleaching. But some of the other events, I think, are much reduced in terms of runoff from the land, in terms of nutrient enrichment, in terms of conditions directly related to sheltered water and higher human populations.
With their differing locations, I'm just thinking like Hurricane Maria, and we're in hurricane season already.
We are.
The topography in St. John and its surrounding vicinity is different than it is in French Polynesia. So when I have a Category 5, now they're talking about changing the categories because 5s are now going to become more standard, so they need to make it a higher number. When they pass through, hurricanes don't just hit the land, they hit the communities under the water. They did some really horrific damage off St. John and the reefs there. And as the reefs started to recover, it wasn't like the whole world stopped and said, okay, we're not going to have climate change anymore, and we're going to let you recover. And then there were more hurricanes, and there were more hurricanes. But the topography in that area changes, I would assume, changes how a hurricane or a water storm would impact the reefs off St. John than they would off Moorea.
Very true. And again, that comes down to sort of the lie of the land, the origin of the islands. Moorea is a volcanic island with a fringing reef around it. It's surrounded by very, very deep water. And St. John is a much, much different location around the edge of the Caribbean plate. The islands are close by. Depending on the direction of the hurricanes, you can have some shelter from hurricane effects by some islands in the way. Other islands can act to focus the storm's energy. So there's all these sort of weird localized effects that make it very difficult to predict the impact of a storm. And so when you hear on sort of the NOAA weather forecast, like, oh my goodness, this big hurricane is coming by and they're forecasting 150-mile-an-hour winds, actually translating those wind speeds into predicted damage underwater is very difficult. You really need to have sort of boots on the ground, so to speak, to measure the water motion underwater, to measure the waves at those particular locations. I've learned that it's very difficult to predict what you will see underwater after a big storm has gone by.
I do remember the images you showed me after Hurricane Maria hit. And it was just, wow. And then a couple years later, you saw life. I mean, it was different life, but there was still life there. I think of coral reefs as very, very fragile, being fragile. Almost like, as I say this as I get older, but an older woman who is still vibrant, but if she falls, her bones are more brittle, and therefore her recovery, it takes much longer. And that's kind of my vision, or not even a woman, a man. As we get older, we become more fragile, even though we like to think of ourselves as being vibrant and full of life and can still do the things we used to do. And I think of that when I think of the reefs. And is the recovery period for something as devastating as a Category 5 hurricane, or worse, taking longer now because of the environmental impact we've had on their life?
Well, I have to be careful with my words here. Fortunately, for many coral reefs and many big disturbances, like Mark Twain, rumors of their deaths have been exaggerated. And so the notion that a coral reef is killed by a storm or everything will die, fortunately, is usually wrong. But the issue is you go from a vibrant coral reef to a less vibrant coral reef, and the pieces are scattered around. And at individual coral colony level, individual coral colonies can be incredibly delicate. They can die from a careless fin kick. They can die from a waving hand from a careless scuba diver. But then on the other hand, other corals can be remarkably resistant to the effects of storms. And the effects of the storms are measured both by what it is they break and they kill, plus what follows that in terms of where the babies come from. And so again, the babies they're little larvae, they drift around in the water column, and they can be the harbingers of the next life. So when we go back and look at a coral reef after a major storm, yes, we look at who has been killed, we look at how many fragments are there, we ponder about how much the abundance has changed, but we're also looking to see what are the first signs of the new babies arriving. And fortunately, the arrival of new babies has been a little bit more resilient than some of the death of the old coral colonies, but I don't know how much longer that will remain.
Thank you for joining us for diving into the discourse. You can watch and listen to more of our podcasts on the CSUN Conversations website and become part of the CSUN Conversations community.